Hello, welcome to Train Signal. You're watching this lesson on the fault tolerance feature in vSphere. In this lesson, you'll be learning what the fault tolerance feature is and how it can provide continuous availability to your virtual machines in case of a host failure. We'll be covering the specific requirements for using fault tolerance, as well as the many limitations that occur when using it, and also show you how to set it up and configure it. Finally, we will cover some tips and best practices for fault tolerance, as this great feature has many caveats that you should be aware of when using it. Fault tolerance was introduced as a new feature in vSphere that provided something that was missing in VI3, the ability to have continuous availability for a virtual machine in case of a host failure. The high availability feature was introduced in VI3 to protect against host failures, but it caused the VM to be down for a short period of time while it was restarted on another host. Fault tolerance takes that to the next level and guarantees the VM stays operational during a host failure by keeping a secondary copy of it running on another host server. In case of a host failure, that VM then becomes a primary VM and a new secondary is created on another functional host. The primary VM and secondary VM stay in sync with each other using a technology called Record Replay that was first introduced with VMware Workstation. Record Replay works by recording the computer execution on a VM and saving it into a log file. You can then take that recorded information and replay it on another VM to have a replica copy that is a duplicate of the original VM. The technology behind Record Replay functionality is built into certain models of Intel and AMD processors and is called vLockstep by VMware. This technology required Intel and AMD to make changes to both the performance counter architecture and virtualization hardware assist, Intel VT and AMD-V, that are inside the physical processors. Fault tolerance works by creating a secondary VM on another ESX host that shares the same virtual disk file as the primary VM, and then transferring the CPU and virtual device inputs from the primary VM, which is known as record, to the secondary VM, which is known as replay, using an FT logging NIC so it is in sync with the primary and ready to take over in case of a failure. While both the primary and secondary VMs receive the same inputs, only the primary VM produces output such as disk writes and network transmits. The secondary VM's output is suppressed by the hypervisor, and it is not on the network until it becomes a primary VM, so essentially both VMs function as a single VM. It's important to note that not everything that happens on the primary VM is copied to the secondary. There are certain actions and instructions that are not relevant to the secondary VM, and to record everything would take up a huge amount of disk space and processing power. Instead, only non-deterministic events, which include inputs to the VM, such as disk reads, received network traffic, keystrokes, and mouse clicks, and certain CPU events, such as interrupts, are recorded. Inputs are then fed to the secondary VM at the same execution point, so it is exactly in the same state as the primary VM. This diagram depicts how fault tolerance works. It's not necessary that everything be sent to the secondary VM to keep it in sync, and only CPU events, disk reads, network input, I/O device inputs, and keyboard and mouse inputs from the primary VM are recorded and sent to the secondary VM via a special FT logging network connection between the two hosts. Note that disk or network writes are not used by FT, as these do not factor into the state of the virtual machine. These inputs are played on the secondary VM, so the CPU and memory state of the VM is identical to the primary VM. Both VMs need to be perfectly in sync in case the secondary VM needs to take over for the primary. The secondary VM sends back acknowledgments via the FT logging network, which are necessary to ensure that the primary VM knows that everything is making it successfully to the secondary VM. The information from the primary VM is copied to the secondary VM using a special logging network that is configured on each host server. This requires a dedicated gigabit network adapter for the FT logging traffic. However, this is not a hard requirement, but it is highly recommended. You could use a shared NIC for FT logging for small environments and for testing the feature. The information that is sent over the FT logging network between the hosts can be very intensive depending on the operation of the VM. All data is synchronized, so there is no loss of data or transactions between the two systems. In the event of a hardware failure, you may have an IP packet retransmitted, but there's no interruption in service or data loss, as the secondary VM can always reproduce execution of the primary VM up until its last output. Fault tolerance and HA can be used together to provide maximum protection. If both the primary host and secondary host failed at the same time, HA would restart the VM on another operable host and respawn a new secondary VM. There are many requirements for using fault tolerance, so make sure you're aware of them all and that you meet them before using the feature. For hosts, the VU-Octep technology used by FT requires the physical processor extensions added to the latest processors from Intel and AMD. In order to run FT, a host must have an FT-capable processor, and both hosts running an FT VM pair must be in the same processor family. In addition, the CPU clock speeds between the two hosts must be within 400 MHz of each other to ensure that the host can stay in sync. All hosts must be running the same build of ESX or ESXi and be licensed for fault tolerance, which is only included in the Advanced, Enterprise, and Enterprise Plus editions of vSphere. Hosts used together in an FT cluster must have shared storage that the protected virtual machines must reside on. This can be any type of shared storage, including Fibre Channel, iSCSI, or NFS. Each host must have a dedicated NIC for FT logging and one for vMotion with speeds of at least 1 gigabit. In addition, each NIC must also be on the same physical network. Network and storage redundancy is recommended to improve reliability. Use NIC teaming and storage multipathing for maximum reliability. Here are some more host requirements. The host must be in an HA-enabled cluster, and host certificate checking must be enabled in vCenter Server. This is usually enabled by default, but you can double check by going to the vCenter Server settings and selecting SSL settings. Now for VM requirements. One of the biggest is that VMs can only have a single virtual processor. Because of this, you may not be able to use FT with some of your more critical, high utilization VMs. Many VM workloads will perform well with just one vCPU, so you might want to try that first if you want to use FT with them. In a future release, VMware will most likely support multiple CPUs once they work out how to keep multiple CPUs in sync at the same time. All VM disks must be thick format, which means they are fully allocated and not thin. If a VM has a thin disk, it will be converted to a thick disk when FT is enabled. There can be no non-replayable devices. This includes USB, serial parallel ports, as well as sound, CD-ROM, and floppy drives connected to physical host devices, and physical mode raw device mappings. Most guest operating systems are supported with a few exceptions that apply only to hosts with third-generation AMD Opteron processors such as the Barcelona, Budapest, and Shanghai processor families. See VMware Knowledge Base article number 1008027 for more detail on this. Finally, all VM snapshots must be removed before FT can be enabled on a virtual machine. You might be wondering if you meet the many requirements to use FT in your own environment. Fortunately, VMware has made this easy for you by providing a utility called Site Survey, which is available for download from their website, that will look at your infrastructure and see if it is capable of running FT. It is available as either a Windows or Linux download, and once you install and run it, you will be prompted to connect to a vCenter server. Once it connects to the vCenter server, you can choose from your available clusters to generate a site server report that shows whether or not your hosts support FT and if the host and VMs meet the individual prerequisite requirements to use the feature. You can also click on links in the report that will give you detailed information about all the prerequisites along with compatible CPU charts. These links go to VMware's website and display the help document for the Site Survey utility, which is full of great information about the prerequisites for FT. You can also click the blue caption icon next to the host configured for FT field on the Host Summary tab in the vSphere client to see a list of fault tolerance requirements. However, this is only general requirements that are not specific to the host. The next release of vSphere will show specific requirements that the host does not meet. Another method for checking to see if your hosts meet the FT requirements is to use the vCenter Server Profile Compliance tool, which is available with the Host Profile feature. To check using this method, just select your cluster in the left pane of the vSphere client. Then in the right pane, select the Profile Compliance tab. Click the Check Compliance Now link, and it will begin checking your host for compliance, including fault tolerance. Let's now look at a demo of using the Site Survey utility to see if our hosts meet the FT requirements. Okay, we're now going to look at using the Site Survey utility to look at our environment to see if it meets the fault tolerant requirements. The utility is available on VMware's website. If you go to vmware.com/download/shared_utilities.html, you'll see the utility there, and there's both a Windows and Linux version of it that you can download and install on any PC. Once you do that, it's real easy to install. It creates an icon on your workspace. Just launch that, and it's going to ask you right away for a virtual center server to connect to. And you can't connect to ESX host with this survey. It has to be a virtual center server. And what it's going to do is connect to look at all the information on that virtual center server and see all the hosts and VMs, all the configurations to see if they're a fault tolerant requirement. So enter the name of the virtual center server and a username and password to log into it. It's now going to connect to that server and generate a report, and depending on the size of your environment, that can take anywhere from 10 to 20 seconds to several minutes if you have a larger environment. And once that's done, it will open up the report in a web browser. Okay, here's the report. Now, let me point out one thing first, that this utility is not perfect, and it's not always completely up to date. VMware periodically, I think, updates this utility, but it's shown here that on both of our hosts that have Intel Xeon CPUs, the X3440 model, that they do not support fault tolerance, when actually they do. If you click on the headings here, they open up links to the help document, which gives more detail on each item. We click on CPU, and we scroll up to there's a CPU chart up here. It shows a little matrix of Intel and AMD CPUs and which ones meet the fault tolerant requirements. The Intel 33XX model is listed here, but not the 3400 series processor is not listed at all. Now, 3400 processor is a little bit newer processor, and if you actually go to VMware's knowledge base, there is a knowledge base article on it's very up to date on the latest processors that support fault tolerance. And if we look here under Intel Xeons, the 3400 series, the Linfield processors are supported by fault tolerance. So this utility isn't completely accurate, but it does give you a good general idea of where things stand in your environment to meet the fault tolerant requirements. You can see here it will show all the virtual machines, and there's headings for the different parts of the virtual machines, like the disk. The VMs must have thick disks. The VMs with the X's have thin disks, which you'll need to convert to thick disks before you can use fault tolerance, or actually the feature will do that for you when you enable it. Snapshots, which are not supported by fault tolerance. If a VM had a snapshot, it would show an X here. The OS, if it has a supported OS. Physical raw device mappings, if it has one or not. Para virtualization, if you're using a PV-SCSI adapter. NPIV, it's not supported. Drives, you cannot have a CD or floppy drive that's connected to a physical host device or an ISO that's on non-shared storage, and we do have a couple VMs here that have that. Now these are all easy things to correct. Once we correct those VMs would meet the fault tolerant requirements. NICs, if the NICs support NIC pass-through, and drivers, it looks at older NIC drivers that may not be compatible with FT. You see here storage, it's showing X's for all mine. It says both the VM and all disks must be on shared storage. Well, bunch of these are on shared storage. We're using software iSCSI for our shared storage. Not sure why it's not picking that up, because that is considered shared storage. Both hosts can access that VM. So this is a good general utility for getting a general overview of your environment to see where it stands to meet the requirements for fault tolerance. So I do recommend that you actually download this, use it, try it out, and it'll give you some of the basic information on where you stand with fault tolerance. There might be a little bit more research that you need to do as far as CPUs and that to see if you are running the latest one. So always check that knowledge base article to see if your CPUs are listed on there. So that's how you use the site survey utility. There are just as many limitations when using fault tolerance as there are requirements. Fault tolerance does not protect against a storage failure. Since the VMs on both hosts use the same storage and virtual disk file, it is a single point of failure. Therefore, it's important to have as much redundancy as possible, such as dual storage adapters in your host servers attached to separate switches, also known as multipathing, to prevent this. If a path to the SAN fails on the primary host, the FT feature will detect this and switch over to the secondary VM, but this is not a desirable situation. Furthermore, if there was a complete SAN failure or problem with the LUN that the VM was on, then the FT feature would not protect against this. Fault tolerance could be used in some cases to replace existing Microsoft Cluster server implementations, but it's important to note what fault tolerant does not do, which is protect against an application failure on a VM. It only protects against a host failure. If protection for application failure is something you need, then a solution like Microsoft Cluster Server would be better for you. Fault tolerance is only meant to keep a VM running if there is a problem with the underlying host hardware. In case of an OS failure on the primary, like a Windows blue screen of death, the secondary will also experience a failure, as it is an identical copy of the primary. However, the HA Virtual Machine Monitor feature, which can detect unresponsive VMs, will detect this and restart the primary VM and then respawn a new secondary VM. Here are some more limitations. It is not possible to take snapshots of virtual machines on which FT is enabled. Endport ID virtualization, also known as NPIV, where you can assign unique fiber channel worldwide node names to VMs, is not supported with FT. You cannot use para-virtual SCSI adapters with FT. You must use the bus logic or LSI logic adapter types instead. Physical raw disk mappings are not supported with fault tolerance. You can only use virtual mode RDMs with fault tolerance. The hot plug feature is automatically disabled for fault-tolerant virtual machines. To hot plug devices, either adding or removing, you must momentarily turn off fault tolerance, perform the hot plug, and then turn fault tolerance back on. EPT and RVI, which are advanced CPU features that can be enabled in a VM settings, are automatically disabled for virtual machines with fault tolerance turned on. IP version 6 addresses are not supported. You must use IP version 4 addresses with fault tolerance. You can only use fault tolerance on a vCenter server running as a VM if it is running with a single vCPU. Even though the requirements for vCenter servers say you need 2 CPUs, you can usually run it with 1 CPU for small and medium environments. Here are a few more limitations. vMotion is supported on fault-tolerant enabled VMs, but you cannot vMotion both the primary and secondary VMs at the same time. Storage vMotion is not supported at all on fault-tolerance enabled VMs. In vSphere 4.0, fault tolerance is compatible with DRS, but the automation level was disabled for fault-tolerant enabled VMs. In the next release of vSphere, you can use fault tolerance with DRS when the enhanced vMotion compatibility feature is enabled. DRS will perform initial placement on fault-tolerant enabled VMs and also will include them in the cluster's load balancing calculations. If EVC in the cluster are disabled, the fault-tolerant enabled VMs are given the DRS automation levels of disabled. When a primary VM is powered on, its secondary VM is automatically placed, and neither VM is moved for load balancing purposes. VMware currently recommends that you do not use fault tolerance in a cluster that consists of a mix of ESX and ESXi hosts. The reason is that ESX hosts might become incompatible with ESXi hosts for fault tolerance purposes after they are patched, even when they are patched to the same level. This is a result of the patching process and will be resolved in a future release so that compatible ESX and ESXi versions are able to interoperate with fault tolerance, even though the patch numbers do not match exactly. Until this is resolved, you'll need to take this into consideration if you plan on using fault tolerance, and make sure you adjust your clusters that will have fault tolerance enabled VMs so they only consist of only ESX or ESXi hosts and not both. See VMware Knowledge Base article number 1013637 for more information on this. Let's now cover how to use the fault tolerance feature. Implementing fault tolerance is fairly simple and straightforward once you meet the requirements for using it. The first step is configuring the networking needed for fault tolerance on the host servers. You must configure 2 separate vSwitches on each host, one for vMotion and one for FT logging. It is possible to put the VM kernel and FT logging on the same vSwitch, but it is not recommended. Each vSwitch must have at least one 1 gigabit NIC, but at least 2 are recommended for redundancy. The vMotion and FT logging NICs must be on different network subnets. This isn't a hard requirement, but it is recommended. This is done by creating a VM kernel interface on each vSwitch, and on one selecting Use this port group for vMotion, and on the other select Use this port group for fault tolerance logging. You can confirm that the networking is configured by selecting the Summary tab for the host, and the vMotion enabled and fault tolerance enabled fields should both say yes. Let's now look at a demonstration of configuring networking for use with fault tolerance. Okay, we're now going to configure the networking for use with fault tolerance. Really, all you have to do to enable fault tolerance is just enable the networking, and once you do that, that server is basically fault tolerance enabled. So here's a host, and we're on the Summary tab, and you see here it says fault tolerance enabled. Currently it says no. You also see this blue little caption icon. If you click on that, it gives you the fault tolerance requirements. Now these are just general requirements. They're not specific to the server. It's not saying that the server doesn't meet these requirements. In the next release of vSphere, it's actually going to tell you specifically what this server does not meet, which requirements it does not meet. So it's currently not enabled, so we have to enable the networking for it. So we're going to click on Configuration and go to Networking. Now what we have to do is either add a VM kernel interface that is enabled for fault tolerance, or add fault tolerance to an existing VM kernel interface. You can do it either way, but the recommended way is to create a separate vSwitch and a separate VM kernel for use with fault tolerance. That way it's dedicated and not competing with other traffic. So I'll show you both ways. Okay, first we have an existing VM kernel here, so we just click Properties and we select VM kernel. And you can see here it says it's vMotion enabled. The fault tolerance logging though is disabled. So if we edit that, we can click the check mark to enable fault tolerance logging. Say OK. Now it gives us a warning basically saying that you shouldn't do it this way. You should do it the other way by dedicating a separate VM kernel port group on a vSwitch to fault tolerance logging. But this way is okay if you have a small environment and don't have a lot of traffic between the VMs. So we just say yes, click close. Now if we go back to the Summary tab, you'll see it now says fault tolerance enabled, yes. So now essentially this host is all ready for fault tolerance. As long as you meet all the requirements, all the additional requirements for fault tolerance, you're ready to go with fault tolerance. So that's it for enabling fault tolerance for on an existing vSwitch and an existing VM kernel. Next, we're going to show you how to create a separate vSwitch to use with fault tolerance. So now we're going to show you the other method for enabling FT logging the networking by creating its own separate vSwitch. Instead of using an existing VM kernel on an existing vSwitch, we're going to isolate it on its own vSwitch, which is the preferred method of doing it. That way you keep that FT logging traffic separate from the rest of your network traffic. So you can see right now the fault tolerance enabled is no. So we're going to go up to configuration. And we have our existing VM kernel here. We don't want to use that. We're going to add a separate VM kernel interface for FT logging. So we click on the Add Networking link. We're going to select VM kernel. And we're going to select a NIC to use for that vSwitch. And for maximum reliability, if you have a lot of NICs in the server, you typically want to use 2 NICs here to make sure that if something happens to the one connection, you have a backup connection. Click Next. Going to give it a network label. You can either go with VM kernel 2 or give it something more descriptive like FT logging. And you can optionally give it a VLAN ID if that NIC is connected to a switch that has VLAN tagging. And then the important thing here is use this port group for fault tolerance logging. You want to check that. Click Next. You need to give it an IP address, and this has to be a unique IP address. It can't be the same as the other VM kernel one that's configured on the host. So unique IP and a subnet mask. And the VM kernel default gateway, that's only set once for all the interfaces on that host. So they need to be on the same subnet, both VM kernel interfaces. So you can either leave that or edit it and change that if you want. Click Next. Click Finish. And you can see now we have a new vSwitch dedicated for FT logging, separate from the other vSwitch that has our VM kernel on it. And if we go to the Summary tab now, and you'll see now that fault tolerance enables is yes, because the networking is properly configured for fault tolerance. So that's basically it. Once we configure the networking, we're ready to start using fault tolerance. Once the networking for fault tolerance is configured, you can enable it on a VM by right-clicking on the VM and choosing the fault tolerance item, and then choose Turn on Fault Tolerance. Once enabled, a secondary VM will then be created on another host. Once it completes, you will see a new fault tolerance section on the Summary tab of the virtual machine that will display information including the fault tolerance status, secondary VM location, CPU and memory in use, and the secondary VM lag time, which is how far behind the primary it is in seconds. And you'll also see the bandwidth that is used for FT logging. We'll now show you a demonstration of enabling fault tolerance on a virtual machine. Okay, let's now demonstrate how to enable the fault tolerance on a VM. Before we do that, I want to show you one key note here that you should be aware of. Normally you can enable fault tolerance on a VM when it's powered on, but there are some situations when the VM must be powered off before you'll be able to do that. If the VM is powered on, you're going to get an error message. And it really depends on the type of processor that's in your host on whether or not you can enable fault tolerance while the VM is powered on or off. So if we look at this VMware knowledge base article here that shows the processors and guest operating systems supported by fault tolerance, scroll down here, it gives us all the processors that are supported. But here's a little caveat here that only some of the VMs can have FT enabled while they're powered on. Others require that the VM be powered off. So depending on your operating system and whether your processor is a Core i7 microarchitecture and AMD 3rd generation Opteron or the Intel Xeon, you may have to power the VM off to enable the fault tolerance feature. You'll basically know that by, if you don't check here, when you go to enable it, you're going to get an error message. So now that we're ready to enable it, this particular server has a processor that requires that the VM be powered off. So to enable it's really easy. Just select the VM and we go to fault tolerance and select turn on fault tolerance. And it's going to give us a little warning here saying that it will take thin provisioned disks and convert them to thick, which can take some time. And some other things it's going to do to the VM. The DRS automation level will be changed to disabled, and it's going to create a memory reservation for the VM. And then we select yes. Now the process will begin, and there it's completed. Now you see that VM here now has a special little icon on it to kind of distinguish that it is a fault-tolerant enabled VM. If we look over here at the status, it's currently not protected. That's because the VM is not running. So let's go and power on the VM. And now that it's powering on, what it's going to do, it's going to create a secondary VM on the other host. And once it does that and powers that VM on, it's going to be protected. So here it is trying to start the fault tolerant secondary VM. And that completed. So now we see the fault tolerant status has changed to protected. It's going to show you some statistics here on the state of that connection. It's going to show you the secondary location. It's going to show you the total secondary CPU, megahertz, and memory that's in use over there. And one key one is the V lockstep interval. This is basically the amount of latency between the two hosts, and it's an important one because if that grows too great, it can affect the performance of both VMs. You'll also see if we go to the other host, you can see that secondary VM is now here. It's listed as secondary. You can't do anything with it. The vCenter server actually controls the state of that virtual machine. So all you can do is view it. It's there. If you go back to the primary and go to virtual machines, you'll also see it there. It looks normal here. You can do your normal things. If you go to fault tolerance now, you can also do a couple actions here. You can completely turn off fault tolerance, which will delete the secondary VM and all the configuration in that. Or you can temporarily disable fault tolerance, which allows you to do some operations you normally can't do while it's turned on, like create snapshots or hot add. Or you can migrate the secondary to another host. Or you can do testing the failover or testing the restart secondary. So that's basically it. That's all there is to setting up the fault tolerance feature on a VM. Here are some tips and best practices for using fault tolerance. Because of high overhead and limitations of fault tolerance, you'll want to use it sparingly. Only enable it on critical VMs that need to have continuous availability. If you enable it on too many VMs, it can really slow down your hosts and VMs. Disk reads will typically take up the most bandwidth on the FT logging network, and if you have a VM that does a lot of disk reading, you can reduce the amount of disk read traffic across the FT logging network by using a special VM parameter. By adding a replay.log read data equal checksum parameter to the VMX file of the VM, this will cause the secondary VM to read data directly from the shared disk instead of having it transmitted over the FT logging network. For more information on this, see VMware Knowledge Base article number 1011965. Once you have enabled fault tolerance, there are alarms available that you can use to check for specific conditions such as FT state, latency, secondary VM status, and more. These alarms are very helpful to be alerted to the condition of your fault tolerance enabled VMs. Let's now look at a demonstration of configuring alarms to use for fault tolerance. Okay, we're now going to show you how to configure alarms for use with fault tolerance so you can be alerted to specific conditions or when the fault tolerance feature is degraded on your virtual machines. Now to do that, you go and select an object in Virtual Center. I'm going to click on the Alarms tab. I'm going to select New Alarm. Now most of the alarms for fault tolerance are located under the Virtual Machines object here. There's two types of monitors, one for specific conditions or state, and the other for specific events. Now there's one important one under specific conditions. So if we go to triggers, click add, and select the drop down here, you'll see there is a VM fault tolerance latency, and that can be equal to low, moderate, or high. That's an important one because that's going to tell you when the fault tolerance, the latency between the two VMs over that FT logging network is getting high. And when that condition exists, fault tolerance may stop. It may delete the secondary VM and try to respawn a new one on the other host. It also may degrade the primary host, which may run at a reduced resource level because it's the secondary can't keep up with it. So that's one important alarm that you want to set. If you go back to general, now we go to specific events, and we go back to triggers, click add. There's a lot of triggers in this one, and if you look through them all, you'll see a bunch that relate to fault tolerance. As we slowly go through, you'll see here there's one like the fault tolerance VM was terminated. Here's another for enabled secondary VM. You don't have to set all of these, but there's a couple key ones that you might want to set. Here's one for reach maximum secondary VM with FT turned on restart count. And if you go down to, this is a key one here, that the vCenter disabled the fault tolerance feature. And one more down here under VM is the fault tolerance state changed. That's a key one that you want to be alerted to. So there's a bunch of different alarms here that you want to set just to make sure you're keeping on top of fault tolerance, and you're alerted when something happens that may either disable or degrade the feature, so you can react to it and take care of it. So that's how to set alarms on fault tolerance. So make sure you do that if you're using the feature, because it can really help you out to stay on top of things. In case of a split brain scenario, such as the loss of network connectivity between hosts, the secondary VM may try and become the primary, resulting in two primary VMs running at the same time. This is prevented by using a special FT lock file. Once a failure is detected, both VMs will try and rename this file, and if the secondary succeeds, it becomes a primary and spawns a new secondary. If the secondary fails because the primary is still running and already has the file locked, the secondary VM is killed and a new secondary is spawned on another host. There is a limit of 4 FT-enabled VMs per host, not per cluster, and it is not a hard limit, but recommended for optimal performance. There is no limit to the number of FT-enabled hosts in a cluster, but you cannot have FT-enabled VMs span clusters. A future release may support FT-enabled VMs spanning clusters. Here are some more tips and best practices for using the fault tolerance feature. Be aware that the secondary VM can slow down the primary VM if it is not getting enough CPU resources to keep up. This is noticeable by a lag time of several seconds or more. To resolve this, try setting a CPU reservation on the primary VM, which will also be applied to the secondary VM, and will ensure that they run at the same CPU speed. If the secondary VM slows down to the point that it will severely impact the performance of the primary VM, then fault tolerance between the two will cease and a new secondary will be created on another host. Patching hosts can be tricky when using the fault tolerance feature because of the requirements that the host must have the same build level, and there are two methods you can use to accomplish this. The simplest method is to temporarily disable fault tolerance on any VMs that are using it, update all the hosts in the cluster to the same build level, and then re-enable fault tolerance on the VMs. This method requires fault tolerance to be disabled for a longer period of time. A workaround, if you have 4 or more hosts in your cluster, is to vMotion your fault tolerant enabled VMs so they are all on half of your ESX hosts, then update the hosts without the fault tolerant VMs so they are on the same build levels. Once that is complete, disable fault tolerance on the VMs, vMotion the primary VMs to one of the updated hosts, re-enable fault tolerance, and a new secondary will be spawned on one of the updated hosts that has the same build level. Once all the fault-tolerant VMs are moved and re-enabled, update the remaining hosts so they are all on the same build level, and then vMotion the VMs around so they are balanced amongst all the hosts. When fault tolerance is enabled, any memory limits on the primary VM will be removed, and a memory reservation will be set equal to the amount of RAM assigned to the VM. You will be unable to change memory limits, shares, or reservations on the primary VM while fault tolerance is enabled. Fault tolerance can be enabled and disabled easily at any time. Often this is necessary when you need to do something that's not supported when using fault tolerance, such as storage vMotion, snapshots, or hot add of hardware to the VM. In addition, if there are specific time periods where the availability of your VM is critical, such as when a monthly process is running, you can enable it for that time frame to ensure it stays up while the process is running, and disable it afterwards. There is a difference between disabling fault tolerance and turning it off completely. Disabling fault tolerance preserves the secondary VM, the fault tolerance configuration, and history so it can be easily re-enabled later on. Turning off fault tolerance deletes the secondary VM and all configuration information and history. Backing up fault-tolerant enabled VMs can be tricky because many backup applications rely on virtual machine snapshots. You should look at alternative methods such as traditional OS backup agents that run inside the VM, cloning VMs and then backing up the clones, or temporarily disabling fault tolerance when you run backups on the VM, and also using storage snapshots to back up the data store that your VM is on. Here are some links for more information about fault tolerance that show more detailed information on how to set up and manage fault tolerance, as well as the link to download the site survey utility to check to see if your environment meets the requirements for fault tolerance. Additionally, there are many knowledge base articles that cover some of the caveats and gotchas that you need to be aware of when using the fault tolerance feature. Fault tolerance is a great feature and provides that extra level of availability that HA could not provide. Despite the many requirements and limitations, you should consider using it for your critical VMs that need maximum availability. The fault tolerance feature will continue to improve in future releases, and the requirements and limitations should be reduced. In this lesson, we have learned how the fault tolerance feature works and how to set it up and use it. We also learned about the restrictions and limitations that occur when using fault tolerance, some tips for using fault tolerance effectively. That concludes this lesson on fault tolerance. Thanks for watching, and I'll see you in the next one.